get started. So, hello everyone, thank you for coming. Thank you to the conference organizers for allowing me to do this talk. This is Migrating Python Web Applications to Python 3. You can follow along there, and I'll remember that second with work.com. So migrating, all slides are there. You can follow along. So, who am I? I'm Wray. I'm a senior software developer at Open. We're hiring, and I plugged to say that, so that's our plug. I'm a Python programmer since about the time that Python 3 was released. I started studying at university about that time and working since then. And I love programming, language, music. What I do during the day is I work on Idea Spotlight, which is a B2B web application for managing challenges the company has. Post a challenge, their employees or customers post ideas for solving those challenges. It's written in Django and Angular. It used to run on Python 2.7, and now it runs in production on 3.6. The rest of the time, I work on Ale, which is a bin plugin for checking your code, which is useful for flight page and MyPy and all those things. And if you like, you can also check out my emo album down there, if you like that kind of thing. So I want to talk about motivation for upgrading in the first place, why would you do it, a process by which you can upgrade, and some challenges that we faced and some common issues to find in your code base, and sort of how to solve those issues. Some motivation. So why would you subscribe to it? This first bullet point I'll get in a second. Some anxiety I feel about performance being a problem. I think it's not a huge deal. There's a lot of bug fixes in the standard library of language itself that will make your code run more easily. There's better types for the standard library. I think the stir and bytes, the way Unicode is handled, and integers, and all your basic functions and types are generally easier to use. And there's a bunch of new features you can use, all kinds of syntactic sugar and nice things. And if you're using Django, so we're using Django in our job, you approach 4-step upgrade. If you want to use Django 2.0 and onwards, you're going to drop support Python 2 completely. Performance. I've seen a few general benchmarks that might give you an impression that Python 3 is maybe a bit slower, and I'm sure it probably is in some domains. Maybe if you're writing NumPy code, it might be a bit different. But I recommend that you don't look at generic benchmarks. You try and run your own benchmarks against your own code base. You can see what the performance difficulty is and evaluate your choice based on that. So I tried doing that with some of our code. So an idea for a challenge is a very common thing that we want to submit. So I submitted ideas a whole bunch of times in Python 2 and 3, just on my machine, and I averaged the time it took for doing it in both versions. And it was slightly faster in 3, but there was no meaningful difference really. I think I could have run them again and got the opposite numbers. So it's pretty much the same. And what we did find later, after finally getting Python 3 in production, though, is our memory usage on our machines that run our Spotlight app went down by about 10%, 20%, or something like that. So that was sort of a benefit we didn't even consider. It was very nice to have. And I think if you go through the patch notes of all the different Python versions, you'll find very core things in the language have improved. Unicode handling is faster, and sorting is faster, and ordered data runs faster. And you can go through each of the patch notes for each of the versions as you go, and you'll find that they're making improvements to the core of the language and things you use every day sort of transparently. And I think the point there is if you want those transparent improvements to the language itself, or the standard library, you have to go to the newer versions of Python. The Python 2.7 is purely going to be maintained for security patches, but certain bug fixes. It's not going to get any new features in the core language itself. And there's a whole bunch of new features you can use when you finally get there. So you can splat your list in your dictionary. List conferences do not get variables. I'll mention that a bit later. Super and class declarations are easier to use. There's more generators everywhere. Generators are very nice. Yield from is useful syntax for generators. Sync await, if you're doing concurrent programming, is very useful. Type annotations for MyPy, more convenient to use in the comments. Python 3.7, interestingly, makes UTF-8 default across all platforms, which is very, very useful if you're doing web development. And there's a whole bunch of new features. But you pretty much can't use any of those new features if you want to upgrade at first. Before you can use any of them, you have to go through a process of supporting both languages at once. And I'll get into that. So how you can upgrade. So if you can remember like any one slide in this entire presentation, I think this is the one that's most important. The high-level process you need to follow is you need to find some way to install Python 3. need to cover your Python 2 code with tests. You ought to be doing that in any case. And then you need to start introducing Python 3 into your continuous integration. So you run your tests both in Python 2 and Python 3. You write code that works with both versions. You get towards 100% tests passing in Python 3 and 2. And then after your tests all pass, you've got confidence that your code works. You roll out development. And once everything works with both versions, you roll out Python 3 everywhere, you just get rid of Python 2, and you're good. So it's a simple process with a lot of complexities in there. You can't just follow that checklist in maybe a week or two and everything's fine. For us, it took us 2 years of not dedicated development, but a little bit here and there each sprint, just doing a bit more Python 3 support, and then we got to the point where it was obvious it all worked, and we shipped it, and that was the end. So if you want to install Python 3, I don't know other distros as well as available with Ubuntu Linux Mint, but if you've got a Debian-based distro, you can apt-get install through this makes repo and get whatever Python version you want. It's pretty easy to do it. On Mac and Windows, I strongly recommend using the official installers. They will probably work very well for you. There's brew and homebrew things you can try as well for Mac. And for other distros, I'm sure there are equivalent ways of installing Python. And if you really get stuck, you can always compile Python. It's actually not that hard to compile Python. It's one of the better projects for just compiling themselves and getting it to work properly. You strongly recommend you use CI. You should be doing it anyway. I strongly believe it really helps you with your quality of code and making sure you don't cause regressions in your functionality as you go. Configure CI however you want. We use Jenkins and some bash scripts. You might want to use Talks and Truck CI. They're very popular now and they're very easy to use. If you find this slide online, you can follow this link over here and I can show it to you later. There's a very simple example I'll put up on GitHub of how to configure Talks and get like a hello world test suite running in both versions. And then you can use virtualenv locally for running 2 different versions of Python. You might want to try Docker or something like that, but generally use CI somehow, get both versions of your local machine somehow, run tests in both versions, and then go from there. You can mark your progress and how well you support Python 3 with your tests. So you can use this PyTest mark to say, I only want to run the Python 3 supported test for Python 3. You could also optionally say, skip these tests if we're using Python 3. I'm using Python 3 symbol from 6. You can use other things as well. And you can generally make progress that way. So you can have 10% coverage next week, 20% next week, until you finally get everything passing and you know that all of your code works in Python 3. One thing that helps a lot with getting more tests to actually run in the first place is you can localize some of your problem imports. So if you've got a module that just does not work whatsoever in Python 3, you can move your import line inside of the function where you use it. Not the best practice in general, but that will help you run more of your tests. So if you have a test situation like this where you have an error that prevents some tests from running say PyTest, you can change your output to something more like the bottom where you have some tests passing, hopefully a lot more failing, but you can start running more of your tests. You have to switch to libraries that work. One thing that's really good is that if you look at the Python wall superpowers, over 90% of the top 200 packages do support Python 3. So it's not that bad, but you probably will find at least one module, a major one, that does not support Python 3. And then you'll have to find a new version or try a different library. You might even have to write your own code or maybe patch the library. And hopefully you can submit that to the open source project as well. But you'll probably hit some problems with packages that don't work, and you have to figure out what to do with them as you go. You have to change your syntax and semantics for all of your code, so you can write code that works with both versions. One thing that I strongly recommend is put this future import line on top of every single Python file in your code base, and I mean that. That will fix differences in the absolute import rules, how the importing works. Division where division returns a floating point isn't always in Python 3, and sometimes using an int in Python 2. That will fix that. Print will be a function, not a statement. So you have to go towards that and go to Python 3. Strings will be strings by default, not byte strings. They'll be text, Unicode, that kind of stuff. Some people don't like the Unicode literals import so much. They prefer explicit prefixes, but choose whatever works for you. And you can use this Flake plugin to help you with this. It takes a bit of configuration with some strange symbols and things, but once you get it running, it will check that all of your files contain these imports, and it'll generally just fix the problem of not having them for you. Some syntax you need to learn to avoid, so don't need to print as a statement, use it as a function, get the future import, it'll work everywhere. This except syntax has been removed in Python 3, so don't use this comma in your exception, use as. It will work equally well in both versions. Next is a function in Python 2.7 and main 3 version, so just use next as a function, not as a method of iterators. And once it's actually come to version 1, I recommend is do not write list comprehensions. Instead, pass a generator expression to a list constructor. And at the addition of 4 extra characters, you'll avoid a problem where the variable for only list comprehensions and only a set of comprehensions, not set comprehensions, not generator expressions, is bound to the function, not to the comprehension itself. It's caused a bug for me where I accidentally changed the value of an argument to a function with something inside of this comprehension, and I've never written them since. But if you go to Python 3, you can just use them as your heart's content. All these can be solved in Python 3, but only after you upgrade and go back to those comprehensions. Don't get your string limits. So treat text sequence types and byte sequence types as being distinct entities. Do not mix them together. And when you want to use them together, you must explicitly encode or decode your data. So if you import this Unicode literals import, then every string will become Unicode in Python 2. It'll become str, which is roughly equivalent to Python 3. You can always use this U prefix in 2.7. For some reason, it's removed in 3 and added back in 3.3. So later versions help. One thing I found in general is that using a more recent version of Python 3 is actually easier than an early one for upgrade. B will give you a str in Python 2 and bytes in 3. And never mix your text and binary sequences. So don't concatenate your text to give you text. That won't work. You can take your text and encode it to get bytes. You can combine them together. And you can decode your bytes, and you can encode your text, and you cannot look at these. So these will actually kind of sort of work in Python 2 until they don't. Don't encode your already encoded data, don't decode your already decoded data. An easy way I find to think about this is think about bytes and text like this. So we have data that is encoded, and then it is decoded, and then encoded again. Or maybe bytes, and then stir bytes. Or at a very high level, an HTTP request is encoded, your application software, and then a database. And often the libraries will handle this for you. So if you're using, say, Django, you'll have text at what you handle your view function. You'll have text going into your ORM and your database logs. And you might not have to handle encoding in those cases. You probably have to handle encoding issues with something more like CSV or Excel documents or anything like that. And there's problems with those. As you go, you will gain confidence in your code for testing. So you know that all your code passes according to your CI. You can roll out Python 3 gradually through all of your environments, testing, and production. And then once you finally get it out there in the wild, you can say, we've done it now, we've upgraded it, call it good. After you deal with a number of issues. Let's get into that. So, one of the first things you're going to do, and you looked into this already, this will be no surprise to you, install 6. It's a great library for forming compatibility there in Python 23. Offers many common symbols between the two versions and just generally normalizes things through the two versions. So built-in is the first thing you're going to run into. So let's talk about those. Xrange, gone, Python 3. Range basically does what Xrange used to do. So if you want to use range, just use range or use Xrange. If you import range from 6.moves, you'll get basically the Python 3 version, which is Xrange 2. And if you absolutely must have a list, just wrap it in a list constructor. You will get a list out of it. You can do this for anything that returns any iterable that may or may not be a list. You just wrap it in a list constructor, you'll make a list or an exception. But worst case scenario, you make a redundant copy, and that's the performance problem. Map and filter. Try not to use them. They're kind of considered somewhat iconic nowadays. Instead, list comprehensions are preferred. Only list constructor or generator comprehension is what I recommend. You can do that instead. So rather than giving map to lambda, you just do this x times 2 for x and something. You can do if x something such as checking for all values there. And it will work equally well in both versions. And if you absolutely must use map and filter, you can import the version from 6. It'll be iterator versions instead of versions from lists, similar to how Xrange and range work. And you can happily use map and filter. Reduce is unfortunately removed as built-in in Python 3. I like reduce a lot, so you have to import it from somewhere. But if you add 6.move to reduce, it'll do nothing of interest really in Python 2, but it'll give you in Python 3. And then you can get the product of a series of numbers or whatever it is you want to do with reduce. I found Reduce to be handy for Django queries for generating cores. It's got a whole bunch of uses in my board. Type check. So the types are different in Python 3. It used to have int and long in Python 2. You have longer integers, you get long. You have str and bytes, and base string is the base of both. What you should do instead is use 6 integer types. It'll give you int or long in 2. It'll give you only int in 3. So it'll be nice and compatible for checking your types there. String types will be base string in 2 and str and only in 3. However, we're using text type instead, which is explicitly the Unicode abstract string type, text sequence type. And you have binary type for when it's stirred to Python 3. And if you must use both in a function, say you have to be sort of literal when you accept, you conservative when you commit, you can just say, give me either binary type or text type, and you can handle that in some way. Iterative dictionaries is going to be one of the first problems you run into. These methods do not exist in Python 3. There's something called keys and values and items. What you do instead there is use the 6 versions, just use the functions from 6. And it will do the same thing as you kind of expect in both versions. One thing that's really handy is you don't actually need to use any method at all for iterative keys. You can just use for key in the dictionary, and in any version you'll just iterate for your keys. If you like the view methods, they're available from 6 as well. View methods, I think they're kind of underutilized in code that I've seen, but they're useful for iterating and changing things at the same time. They have their uses, so they're very handy. This could be an entire talk on itself. It's a huge subject. I'll barely scratch the surface, but really try and use text as much as you can, not bytes. If you're working with, say, web application software, not something like IRC client or something, try and stick to mostly text. The U prefix will always need Unicode at 2.x and 3.3 and onwards. B is available pretty much everywhere. And we tried using explicit literals and all of our string values first, but later went to Unicode literals. It just as we closer to actually getting Python 3 support in those things. Always explicitly encode and decode. I can't stress this enough. Do not use the default encoding, because often you get ASCII, and if you're doing web stuff, that's not handy when you haven't written out in your text. It does not go very well at all. Here's a very, very formatted version of how to decode text conversion. We'll do that in a second. I do not recommend copy pasting this code into your codebase. You're free to do so if you want to, but there are better libraries out there for handling this kind of thing. So the general idea is, say you have any value and some encoding, default is usually a vague or a case. You can take a value, check its bytes, if it is, you decode it, and you get text. So that's stir in 2 and bytes in 3. Then every other case, you pass it to your Unicode text constructor, so text type, which is Unicode in 2 and stir in 3. And then if you have text, you get text. If you have an integer, you get text, etc. Or exception, of course. 2 bytes, the other way around, just pass it to the toText function, re-encode the data first. So if you have UTF-16 byte sequence, you don't want to mix that with UTF-8. That won't go so well, so just decode it and re-encode it as UTF-8. Bit of performance overhead, but you can handle that as you need to. If using Django, just use force text and force bytes. They're kind of hammers, but they will generally solve your problems. They will give you bytes or text one way or another, or they will throw exceptions. They will solve bugs pretty easily, but proceed with caution. One of the things you'll run into really quickly with web development is importing all the URL versions. So this works in Python 2. This is what you do in Python 3. And with 6, this is what you should do instead. So just put that 6 moves in front of the Python 3 version, it'll work equally well. They restructured all of URL to be a bit more sensible, but of course every restructure means it's not compatible, so that will cause you import errors pretty early on, so you get issues pretty easily. And in Django, I highly recommend using the Django versions of these functions instead for code plus and your own code, because the Python 2 version doesn't handle Unicode text sequences as well. I don't have time to get into that, but if you want to know details, I'll speak about that later. So unfortunately, I don't have too much time to go through all the issues that you'll experience. There are many, many of them. And I'll also speak briefly about these issues here. So I already mentioned Unicode is not handled so well for URL code. Probably give you weird exceptions for ASCII and whatnot. You cannot sort with none. So if you have 1 and none, you can't use less than with that. So the sorted stopped working, group by stopped working, but you can add a key function that sort of coerce none to 0, etc. CSV is wildly different. So you might have to install, say, Unicode CSV's library that bridges the gap. There's no CMP function for sorted or group by to use that. There's a function for converting from CMP key. Thunder stir, you have to use only that Python 3, and there's this decorator for your class you can use to fix those problems. Meta class is just different syntax, and 6 can help there as well. And one thing I just want to recommend is never format bytes into text. It will give you the wrapper of your bytes, and that can cause really great bugs with all kinds of stuff. Also, dot format has the same problem as well. So, explicitly and decode your bytes before you run your text. And that's all I have time for, but I have a little bit of time for questions. I'll say in conclusion, Python 3 is the future. Migrating will be hard at first, but I think after you've gotten there, it'll be really nice to see Python 3 is also nice features. And if you're going to upgrade, start now, because it will probably take you some time. Thank you.
Through some minutes of questions. I usually disclaimer, please make a question, not my story. Yes.
What's the best way to automate some of this? Because it seems like a lot of manual work.
Automation is a good question. There's some tools like 2 to 3, but they don't work very well at all on a large code base. Generally, I don't think you really can automate it. I think your method of automating is run tests. And you just go, this code is wrong. You have to manually go in and change that bit of code to make it compatible. I don't think there are that many tools that convert Python 2 to 3 code very well. There might be more tools out there, but generally it is a matter of process of rewriting parts of your code to be compatible. Fortunately, I will say it's not that cheap once you get into it.
Questions? No?
Is there a reason why for 3.6 and not 7?
Yes, because 3.7 hadn't been released at the time we started doing migrating, and we started installing 3.6 across all the machines, and now 3.7 has come out. We might consider going there eventually, but now we're there. But that's another process of we need to make our code compatible with Python 3.7, and then we'll go there as well. Same process basically, just install 2 versions. Yeah.
Sorry, and all your new versions is all running accounts?
We use Talks for some. So we just had Jenkins and some bash scripts. We just go, run PyTest in this version, run PyTest in that version. We could have used Talks and Travis CI or whatever if we had known about it at the time. I highly recommend you do use Talks, because Talks is a very useful tool for running many versions, especially with Travis CI, it's got really good support for that.
Thank you very much.